Welcome to qnawire.
So here in this problem we are given that the tire has a mass of 0.8 kg and the radius of the tire we have 0.32 meter and the moment of inertia above the central axis we are given as 0.83 kg meter square. Its initial velocity we are given as 2.1 meter per second. And he see that the tire leans 20 degree to the right, as you can see in this figure. Now there are two parts in the equation. In the A part we have to calculate effect of the resultant torque on the motion of the tire. Now the torque produced by the normal force above the center of mass will change the angular momentum. So the torque will change the angular momentum of the tire, and the tire will turn in the direction of the lean. That means the tire will turn to the right side from the front view. So this was the answer for the A part. Now in the B part we have to compare the change in angular momentum in 0.2 second to the original angular momentum. So if we use the Newton's second law in terms of angular momentum, it is sigma tau is equals to dl over dt. That means a net torque is equals to the rate of change of angular momentum. So from here the rate of change of angular momentum is equals to sigma tau net torque acting on the body times dt, and dt in the equation we are given as 0.2 second, and net torque in this case would be r cross fn. Now but we don't have the value of fn, so for that again we can use the Newton's second law of motion, which says that net force is equals to mass into acceleration. Now if you see the net force in the y direction, there is no acceleration, so this term would be 0. So net force in the y direction, that means in the vertical direction we have Fn, which is acting in the upward direction, minus mg, which is acting in the downward direction, is equals to 0. So from here Fn is equals to mg. Now we can put this value here. So net, this is dl, this is net torque, which is r cross f. So r cross fn we have mg times dt. Now from the concept of cross product we can say that r cross mg will be equals to r mg sine theta and dt as it is. Now we have all the values, we can plug it here to calculate the change in angular momentum. So the radius of the wheel we have 0.32 meter multiplied with the mass, which is 0.8, and g we have 9.81 meter per second squared. Sine theta is 12 degree, so 12 degree times dt, and dt is 0.2 second. So I can repeat this. So this is 0.2 second. So from here we'll get the change in angular momentum as nearly 1.04 kg meter square per second. Now next we'll be calculating the original or the magnitude of the original angular momentum. Now the angular momentum is also defined as L is equals to I omega. So I, we know it is given in the equation as 0.83 kg meter square, and omega is V over R in this case. So we are given as 2.1 meter per second. It is the initial velocity divided by the radius is 0.32 meter. So from here we'll get the initial angular momentum as 5.5 kg meter square per second. Now if you compare the change in angular momentum to the original angular momentum, it will be dl over L naught. So this is 1.04 kg meter square per second divided by L naught, we have 5.5 kg meter square per second. So from here we'll get the result as 0.19. Therefore, we can conclude that dl is equals to 0.19 times L naught. So this is the final answer for the given problem. I hope you have understood the problem. Thank you.